going to be on the quiz.
This is not. But it was on the last one, wasn't it?
Yeah.
So it will be on the test. I have the answer.
Okay, when you have like either compression or stretch,
Yeah.
do you always for like the first part, is it okay if you go like up, let's say 2/3 and go like up 2/3?
You should not actually go up 2/3 when drawing it, but that helps you know that it's going to be wider. When you forget, how should you draw it? Just draw it wider than normal. If I wanted an accurate graph, I would say give me a T-chart and get your graphing calculator out. Okay, all that's there is, right now you're identifying that 2/3 means wide or skinny? Wide. You knew that right there was a horizontal stretch, a vertical compression. That's all I really want you to realize about that A term. Okay, you better not walk into Mr. Beal's class, okay, next year knowing that, okay, that 2/3 right there was the slope. Okay, it acts like it. You can go up 2/3, and that tells you I better put it outside the vertical or outside the U. All right, check it with your neighbor next to you. Okay, show them your graph. Tell them how great they are, because they have the vertex labeled. They have the line of symmetry labeled. They have a dotted line for the parent function, and then give them an A+ for this quiz. All right. What's that, Shelby?
A+.
We don't learn anything new, no. Okay, here's problem number 2. This one's going to challenge your 60-second rule, because you got to actually write and think and do some math at the same time. This is not one you can dance to too easily. Okay, it is? Well, I'm glad you think that. Go ahead. Marks are set. Go. Time it on there. All right, gun release. Boom. Whoa, I got you rocking. Good job.
So the quiz today is
Oh, you only have 15 seconds. Don't panic. Because we don't want that to happen on the real quiz. Be nice, calm, and collective. Oh, I know. So nervous.
Do you think, are you just trying to get us nervous?
I am just trying to get you nervous.
Then you give us a test.
You'll be all nice and easy. Yeah, that's what it is. All right, line of symmetry looks like we have it at -3. Okay, so if I was to actually do this in 30 seconds, I would have, okay, a dotted line. Did you label -3?
Yeah.
Okay, from there I have to find the vertex, so I have to plug that back in. So I have 2 times -3 squared plus 12 times -3 plus 11. Y equals -7, because did it spit it out, right?
Yeah.
-7? No. What is this supposed to come out to be?
-7.
No, oh yeah, that's a little bit further than that. -18 though, right?
No. No, it's...
No, that's 18. That's 18. That's -36. That's 11. So, it was -7.
Yeah.
Yeah. You guys are testing my
I thought you
patience.
said 2 times day5.
Oh yeah, see, I was just the calculator going up here. So, all right, so -7 down. Okay, so we have -3, -7. Is this thing gonna go up or down? Up. It's gonna be wide or skinny?
Skinny.
Okay, so we draw normal. Okay, and again, if I wanted you to draw it accurately, I would just say do a T-chart, plot it in your graphing calculator. I just want to know when you're done, you knew that this thing was vertically stretched, creating a skinnier graph.
Wait, so for the parent function,
Okay.
you just want to
The
draw.
parent function is just a dotted one at the vertex. That helps me tell.
I know, but you just want to like, not like accurately put it on.
Yeah. Right. All right, here we go. Question number 3. So I did one in vertex form. I graphed one in standard form. What form is this one called?
0. It's like,
Not standard form and not vertex form. I like that answer. Okay, which we call intercept form. Okay, and we wrote down a form that looked like this. Okay, where y was your function. Okay. What does this form help me find again? Because, with the vertex form, I found the vertex, and that was an easy one to dance to. Because you could see the left-right shift, the up-down shift. You can see if it's wide or skinny. Standard form wasn't much of a dancing function. All you could really do is see if it was wide or skinny. You can see the y-intercept, but I don't know how you call that a dance. It's like a big hop or something. Okay, so this one right here, same thing. This thing, is it going to go up, down, wide, or skinny? Up and skinny, because we know the 2 is the stretch function. Okay, we know it's going up. Okay, but the one thing that we can find right here, okay, is we can find the x-intercepts. Okay, so when we find those x-intercepts, okay, our p and our q values, okay, that's what you were meaning? Yeah, I got ahead of myself when I was doing that. Okay, so we got our first one at -1, and our second one is at 5, right? Okay, so we have our x-intercepts. 1, 2, 3, 4, 5, and -1. Alright, now what? You guys told me it was up and wide and skinny, so yeah, you just come up here and there you go. It's pretty good. That's true.
find the vertex.
Find the vertex. You just kind of put it wherever you want.
Well, it's halfway in between the 2 and 1.
There we go. We know it's halfway in here. I know we found the vertex this way in standard form. Okay, but in vertex form, we take the p-value and the q-value and we average them together. The common mistake that happens here is we forget to add them. Okay, we actually subtract them. So always when you're done, look and see if it actually looks like it's in between there. Here I have -1 plus 5 divided by 2 is 4 divided by 2 is 2. Okay? So I have 2. So if I got my line, my line of symmetry to be over here, is that good? No. Okay, always, think about, where you're putting that line of symmetry right here. Okay, I have that thing at 2 right there. Okay, it makes a lot more sense. Okay, so I got my line of symmetry, label that thing, x equals 2, and now what? Plug it in, because can I just come up here and do this? No, we got to know how far down that goes. Okay, so I'm going to take this line of symmetry, which is x is 2, okay, and I'm going to plug in 2, back into that equation right there. Okay, when you plug it back into that equation, that will help us find that y-coordinate, for the vertex. Okay, so I plug that in, y equals 2 times, let's see here, 2 plus 1 times 2 minus 5, y equals 2 times 3 minus 3. Oh, this one goes down a long ways, doesn't it? Yeah, -18. So I guess if I was really to graph this thing, it shouldn't look like that, but it's going to be probably way down here. So 2 -18. Now, the one thing I always have someone ask me is, do I need my parent function? Well, the x-intercepts didn't enforce its width. Yeah, so I could see an argument saying, well, I know that this skinny, I know its size because the, this x-intercepts forced it. Okay?
on the test, if it's like really, it's below a graph, you just want us to like, what do you want us to do?
Yeah, just estimate.
Just put it down.
Yeah, just put it down there somewhere.
Okay.
Okay? Alright. Any questions there? Alright, how are we doing on a scale of 1 to 5 here so far? Alright. Now, I'm going to do things a little bit backwards. I'm going to give you the graph, and you find me the equation. Okay? I'm going to skip this one for right now. So I'll come back to this one. Because I ran out of time the other hour. So remind me to come back to this one right here. First of all, if we just looked at this one. Tell your neighbor right now, does this one go up, down?
It goes down.
Down? Why down? Doesn't it have a 1 out in front?
Well, yeah, but if you factor that.
If I factor a GCF out of that, I would factor a negative 1 out, making this x minus 1. Is this thing wide or skinny? Or is it normal?
Normal.
You would think so until you realize there's a GCF there too. Okay, this is x plus 2, and when I factor a 2 out of this, this is what it actually ends up looking like. Okay?
There we go.
Be careful on those. Okay? When you're doing it.
Wait,
Okay?
can you
Yes.
also foil that out?
You don't have to fill it all out. You just have to graph it now, like we did on this one right there.
The original. Like,
Could you foil it all out? Yeah, but remember your test, you only have so much time, and then you're going to be doing that extra work and, you know, going from there. All right, this is where I wanted to get to. Okay? I'm going to give you the graph, and you say, now, what the equation is. Okay, you have the graph. I want to know the equation. So you're given a function, and the one thing I didn't write up here in my words, you're given a function, and this function, obviously, as you can see, it is a quadratic. So f of x is a quadratic from the picture. Okay, with the zeros, negative 3 and 5. And I did give you the vertex of 1, negative 2. Now you have 3 formulas, or at least forms to choose from. Vertex form, standard form, or intercept form to write an equation from. This problem, actually 2 of them, I would accept the form in. It's just the question, which one do you guys think would be the easiest one to put this problem into? Vertex, or standard, or intercept? Luis, what do you think? You think vertex is the easiest one right there? Yeah, we all think that one is. Now what happens if all of a sudden I erased that coordinate right there and I gave you another coordinate right up here instead? Intercept. Because what you're going to do is, in order to find a formula, you're just going to need the P and the Q and one other point. You're going to need the vertex plus one other point. Either way. Okay, so I have another one that's going to use vertex on the next slide. So let's do this one using intercept form. Okay, so I'll go back here. What was my vertex again? There we go. Negative 1, 2. So I'm going to plug in 5 in for P and negative 3 in for Q. Okay, so we have y equals a times x minus 5 and x minus negative 3. Okay. Alright. Solve there for, what are we missing? The slope, the A. Okay, that compression or stretch factor. Okay, how are we going to go about solving? All right. Go ahead and take this coordinate that we have right here. Plug the y into the y value and the x into the x. This stuff is not on the quiz. This is new. Okay. The stuff I told you that was on the quiz was yesterday. Okay. The factoring and the application. Okay. This stuff is on your homework assignment for tonight, though. Okay. Alright, so we have -2 equals a times, well, I plug in 1 minus 5, 1 plus 3, -2 equals a times -4, and 4, -2 equals -16a. Divide by -16, and a equals 1/8. Right. Do we have enough to fill in that equation? Yeah, there we go. So we have, okay, and I put y there, so I think our function, I wanted to call it f of x. So f of x equals 1/8 times x plus 3 and x minus. Any questions on intercept form? Nope. I might want to blow that up for some of you there in the back of the room. Jen, what do you think this time? What formula should we use? Vertex, standard, or intercept? What did I give you up here that you could automatically kind of keys into what you want to use? Yeah, the vertex. Because did I give you any x-intercepts this time? No. Okay, so I gave you that vertex. And with that vertex, we at least know the h and the k. Okay, and I wanted to call this g of x, so I better call this here g of x equals a times x minus 1 plus. Now the reason I was going to put y in there instead of the g of x function here is, okay, you're going to plug that 6 into the x. Okay, 6 goes into the x, and your -11, okay, goes into, you know, where your y is. Okay, I just want to make sure you guys realize there's a function notation. Okay, that g of x is representing the answer. Okay, so we had -11 equals a times 6 minus 1, the ground is. What's that? Plus 4, yeah. Plus 4, yeah. So I know I've been going kind of fast, but I just can't wait to get to this next one.
Is it going to be using standard form?
No.
Or is that
Actually are kind of using standard form, so I should say yeah.
Or they use like 5.
Okay. Negative 11 equals 25a plus 4. Subtract 4 from both sides. 25a equals negative 15.
Wait.
So negative 3/5, is that what you guys got?
Yep.
Okay.
Oh, it's negative 11?
Well, that's what I got right up there. Negative
Okay.
11.
Yeah, I thought it was
That's right there. So my equation. I didn't really need this graph, okay, but if you wanted to plot it, you could. G of x equals negative 3/5. Plug that part in right there. X minus 1. The quantity squared plus 4. What's that, Legend? Got it?
Yeah, you said my next question.
Oh yeah. Okay. You good though? Alright, so how are we doing on a scale of 1 to 5? I've been going very quickly today. I couldn't wait for this next example. Okay. I'm just going to give you 3 points on the quadratic. And none of them are the vertex points. And none of them have to be the x-intercept. Actually, one of them's the x-intercept. It doesn't do you any good if you don't have the other pair. This right here is actually a systems of equations problem. Okay? And it's going to be a systems of equations with 3 variables. Okay? Because we are going to use standard form. Mister?
Says on fx is f of x is equal to x squared as a fair function.
Yeah, so in other words, I would have to say that these 3 points make a quadratic. That was the way that I was trying to verbally tell you.
Should it be on the equation of everything besides fx?
It should probably, yeah. I should find the equation of g of x given the following points on g of x. Yes. Okay. All right. There's our standard form. I'm going to take this first point, and I'm going to plug in the y-coordinate in for y, and the x-coordinate into x. Okay, this will give us negative 2 equals, you better double check me. I've already made out 2 mistakes on the worksheet, so I don't want to make another one here. Is that what you guys got for the first equation that I had there in red? Let's use that first one. The 9 I took negative 3 squared. Negative 3 squared is positive 9. You know, I didn't do this. You know, I just kind of did this in my head. You guys all good with my mental work? I very rarely do that, so. Okay, I'm going to plug. Now, the second one, I get another equation. Okay, I'm going to have 1 equals. Okay. Sorry, I knew something's up. I got to do that to get backwards. Going backwards. Put 10 in here instead. So 10 equals. Okay, I got to put the 1 in here. So I have a times 1 squared plus b times 1 plus c. I'll write it out this time. So you got 10 equals a plus b plus c. So there's my first equation. There's my second equation. Okay. I can make one more out because if I have 3 variables, I'm going to need 3 equations. So I plug in the y-coordinate in, so I get 0 equals a times negative 1 squared plus b times negative 1 plus c. So 0 equals a minus b plus c.
Wait, negative.
Good? Questions now on what I just did to find those equations? I'm not going as fast now. I wanted to slow down a little bit. Alright. What method did you guys prefer solving systems of equations? Do you want to use graphing, substitution, or elimination? You guys all said the same thing. I would agree. Okay, so which two equations look like the easiest two to work with first?
Green one and blue one.
The green and the blue. Okay, so we'll take that green one. 10 equals A plus B plus C. And we'll take that blue one of 0 equals A minus B plus C. And you always, in elimination, you should always add. In this case, is it do we add and we'll eliminate one of the variables?
Only have two. Try not one.
You could. That would be clever, but we're not going to be clever because this doesn't always happen. That the two of them. You could eliminate two variables at once. That would be nice. Okay, but in this case, I'm going to add them together, and I get 10 equals 2A. The B's cancel plus 2C. All right. Now, the next thing is you got to pick two more equations. They have to obviously can't be the green and the blue. I don't care which two you pick. Okay, it can be the red and which other one?
The green.
The green? We're fine. I'm fine with that. So we got negative 2 equals 9A minus 3B plus C. Okay, and we have the green one, which is 10 equals A plus B plus C. Now I only have one huge rule you got to put down in your notes. You must eliminate the same variable. You must eliminate the same variable. So what variable are we forced to eliminate with the green and the red equation?
B.
The B. Okay, so we're going to have to eliminate this. Okay, we're going to make this one to be a 3B. Okay, not, a negative 3B, so I'm going to times both sides by 3. And I'm just going to rewrite down here. I have 2 equals 9A minus 3B plus C. 30 equals 3A plus 3B plus 3C. Right, B's are going to cancel. Beware of front row flying objects. Okay, so we have 28 equals 12A plus 4C. Now, I'm hoping, now that you see the two black equations, a little light bulb will come on here. Maybe dim, but I hope it comes on. And what does that light bulb, boop boop, pops up, and what's it say?
You can do with this new equation.
Now we have two equations right here. Can we eliminate one of those variables? Okay. So I'm going to take this 10 equals 2A plus 2C. I'm going to take this 28. Ooh, that's a bad 28. 28 equals 12A plus 4C. And what variable would you like to eliminate this time?
C.
You guys all agree C this time?
No.
Oh yeah, C.
Okay, C's the easiest? I think it is too. Okay, but just make sure when you do eliminate the C, you times, okay, so you get them opposites of each other. So I'm going to times by negative 2 here. Okay, and when I do that, I get negative 20 equals negative 4A minus 4C. 28 equals 12A plus 4C. This is getting to be like the Euler's line, isn't it? You can see that right now you're starting to like this. Euler's line, now all of a sudden I see some of you starting to get the shakes already. Just say that word.
No.
That's Shelby.
Okay, like way back at the beginning, not at the beginning, but like when you found each equation, could it give like that phrase compound?
On
Like, for the 10 equals 2a plus 6, you could have just divided by 2 and make that 5 equals a plus 2.
you could divide that out, yeah. And that would have been fine.
I think it would have made
It could have been. That's something to always see. Yes. Okay. Well, I'm right here, and I add these together, and I get 8 equals 8a, and what do we get for a?
1.
All right. Oh, by the way, what in the world is a?
B.
It's just exciting that we found a. Woo, yeah! I got a. What in the world does a stand for? All right, there we go. That's the slope, the compression or stretch factor. Okay, so in this form right here, I just love the look on some of your faces like, man, you thought what I was thinking.
Pretty much right.
You're doing all of this stuff right here. I don't even have a clue why I found a. Okay, well, I got 1, okay, x squared. All right, woo, yeah.
Yeah.
Okay, all that work, yeah. Can we find, which one would be the next easiest to find? C. Okay, I can find C. I can plug it into either one of these equations right over here. Okay, so if I plug that A in right here, I have 10 equals 2 times 1 plus 2C. So I got 10 equals 2 plus 2C. I think, Shelby, that's probably one place it would have been easier if I would have eliminated those 2's. It could have made this nicer. Whoops, divide by 2. And I got C is, you guys get 4?
Yeah.
All right, so I just found C, I got A. So, by the way, before we take that quiz, what's the C value represent? The y-intercept. Okay, we only have B left. So you're going to have to go back to the original equation. Okay, right back here. And we have A is 1. Okay, we have C is 4. Okay, which equation looks like the nicest?
A minus B.
A plus B plus C. Okay, so we got 10 equals 1 plus B plus 4. So B comes out to be 5.
Yay.
Holy cow! After all of that, you start running around the kitchen celebrating. Okay, that we have the function, and I think, Drew, you said to put that as g of x. So is that this one, or was that the other one? That was this one, because that's such a long time ago. Okay. No, you got an equation. That's all I asked for. It doesn't matter what form it's in. And now here's for the good thing. You guys remember that day after Euler was lying, and all of a sudden I came back and I told you there was a shortcut?
There is a
All
shortcut.
right. You want me to wait till the next day to show you?
Yes.
No.
Okay, I'll show you on Monday then. All right, get your graph calculators out. I'll show you how this can be done in 5 seconds.
Oh,
Let's go through graph calculator. Okay.
you can add like all of them together and divide by 3 and then like.
Okay. Why did I learn this? Because were you taught systems of 3 equations in Algebra 1? And if you were or were not, you have now been taught this, and this textbook uses this. So I had to show you at some time. They actually cut this out of the curriculum, okay, and said, oh, you're supposed to be exposed to this earlier, and we haven't. So no, now we have. Okay? I'll ask you to do 2 of them long-handed, and 1 of them using your calculator. You can always use your calculator quickly. But... All right. So to use your calculator here. Okay, the first thing that we want to do here, okay, is you want to push the stat key. Okay, we're going to take these 3 points, okay, and we're going to hit edit, okay, select edit, and plug in your 3 points, your 3 coordinates. I got them up here for you if you didn't remember what they were. They were -3, -2, 1, 10, -1, 0. Now, if one of you has a whole bunch of garbage in there that you want to get rid of, just go up to the L2 and hit delete, and it deletes everything in there. Go over to L2 and hit delete. My list 1 is the X coordinates. My list 2 is the Y coordinates. No, stat, right here. Right there, stat.
Oh.
You guys see it right here? Push that one right there. Now, does anybody not have a list 1 and 2 on their calculator? Okay, then I am going to reset your calculator instead of trying to get it on there. Okay, do you have wonderful games on here that you're going to cry about? Do you have a program? Okay, well, you don't need one. Okay, so it's fixed. Okay, you can go back and get it from now. He'll give it back to you. Okay? Alright. I could have changed them, but I don't have time right now.
Can I borrow a calculator?
Okay.
No.
Who said that?
Yeah.
Yeah, you can trade me. Okay, now we're good. You hit memory reset. Anybody else? Need theirs? Need a calculator? Go over there, trade me. Okay, something that's an ID I prefer. Okay? Alright, we all got it there?
Yes.
I know those of you that just get in the calculator, you're going to be running behind here. But are you ready for the magic key? Okay. All you have to do to calculate this equation, you got to go back to stat here first. You got to go to calculate. And you got to tell it what type of equation are these 3 points going to make. Do you want these 3 points to calculate a line, or do you want them to calculate what? A quadratic equation. And what it does is it starts doing a regression formula. What that means is it takes the values it gets and plugs them back in and plugs them back in. You know, that's just a fancy way of saying we're going to take a quadratic equation and make it. You should get this right here, quadratic regression, to pop up on your screen. And after you hit enter, ding, there's the A, there's the B, and there's the C. Amazing! If it doesn't work for you, you're not going to talk nicer to that calculator.
Wait, how do you do it?
Okay, so again, we go into stats. Okay, we got to hit edit. Okay, we got to type our 3 coordinates in there correctly, making sure you use the negative sign instead of a minus sign. Okay? Once you got them all in there, go back to stat. Hit calculate.
Yeah.
Quadratic regression. Hit enter, and voila. Amazing. You get all that Alexia or not? I recorded it for you, so if you need to go back and get that.
I think I'm going to calculator.
What is the r squared plus 1? You ask that question when we come back, because that's a good question. That tells you how valid your answers are. This means it's 100% correct. Because sometimes that point may be just a smidge off the line, and they had to kind of smudge the answer a little bit. So the closer you get this number to 1, the more accurate that equation is. Okay? All right. So there, those that are listening to the worksheet, they got that. So I can hit stop. Maybe I'll just hit pause.